So this mind map outlines the structures, processes, and significance of memory, showing how information is acquired, stored, and retrieved, and sometimes distorted across time. So let's begin with the processes of memory, which involve acquisition or encoding, which is getting that information ready for our memory. This is followed by storage, the retention of that information over time, and finally its retrieval, allowing us to access that stored knowledge. These processes form the foundation of all memory functions. Next are the systems of memory, which describe different storage stages. So sensory memory is the first stage. This briefly holds raw incoming information from our senses just long enough for us to notice it. For vision, this is called iconic memory, which stores a fleeting visual, and for our auditory system, or our hearing, it's called the echoic memory, which holds traces for about 3 to 4 seconds, allowing us to piece together speech and sound into something meaningful. From here, information can pass on into our short-term memory, our working memory, a limited capacity system where we actively hold and manipulate material. For example, remembering a phone number long enough to dial it. With rehearsal or deeper processing, this information may then enter our long-term memory, which has an almost unlimited capacity. So some of this knowledge may remain indefinitely in what we call the perma-store, like remembering your childhood home or how to ride a bike. So there's also 2 types of long-term memory. Explicit memory, or declarative, involves conscious recall and includes semantic memory, our stored facts, and episodic memory, our personal experiences. Implicit memory is unconscious and includes procedural memory or skills, as well as priming, habituation, and classical conditioning, which we've previously discussed. The mechanisms of memory highlight biological and cognitive underpinnings. So long-term potential strengthens neural connections through repeated activations, so supporting our learning. The hippocampus plays a critical role in forming new episodic memories, with the amygdala, while the amygdala attaches emotional significance to these memories. So the schemas, or mental frameworks, also guide how we encode, interpret, and retrieve information, but they can also introduce some bias. It's powerful but imperfect. It can fade with decay, be disrupted by interference, and is reconstructive, which can create false or distorted memories. Over time, memory changes, so things like infantile amnesia limits early recall, flashbulb memories capture emotional events vividly, and errors like source confusion or cryptomnesia show how memory can mislead us. So altogether, memory is both enduring and flexible, but always vulnerable to error and change across one's lifespan.